Hello everyone, I'm Bernice Karisaneda Bursirai from Intan Permatahati Christian Junior High School, and today I'm going to present my paper entitled Rhizobacteria factor in Marsilea crenata, Semanggi Suroboyo as an anti-pollution in SIER Lake Surabaya, a laboratory study in reducing water pollution in the new normal era. Well, first of all, as an introduction, Semanggi Suroboyo is Surabaya signature dishes made of water plant Marsilea crenata. While Marsilea crenata itself is able to do bioremediation, which is the breaking down of harmful matter into a more safer compound. However, it might cause some negative effect on our body, knowing that the plant absorbs the harmful matter, and that way when we consume it might be poisonous to our body and cause something like leukopenia. Well, what is the harmful matter here? It is the cadmium and lead that have caused problems in Indonesia water, such as in SIER Lake Surabaya. It is caused by the industrial waste from factories that is disposed here, causing the numerous fish to be dead and causing bad odor. And also regarding to the new normal era, government has set some washing hand protocol to make us wash hand. However, the water here is water from around us, such as water from river, so we can conclude that if the water is polluted, then our hands will be unclean, knowing that the water is unclean too. So the government wants us to maintain cleanliness. To enable this goal to be reached, we need to reduce the water pollution. One of the way is by planting Marsilea crenata in the water polluted area. Well, the general objective in this experiment is that to help researchers to understand about Marsilea crenata bioremediation in reducing water pollution, and to research further around Marsilea crenata bioremediation in reducing water pollution. However, there are some specific objectives, such as proving Marsilea crenata bioremediation and ensuring the effect of the amount of cadmium and lead in SIER Lake Surabaya, if it is one of the factor of water pollution or not, and there are some other objectives. Well, after knowing the objective and background, we can sum up into one research question, which is, can the bioremediation ability of Marsilea crenata reduce the water pollution in SIER Lake Surabaya and affect the turbidity of the SIER Lake water? Well, the hypothesis is that initially the amount of cadmium and lead in SIER Lake Surabaya water is above the threshold value, and it also have a high turbidity. However, by planting the Marsilea crenata, the amount of cadmium and lead of the water decrease, and also the turbidity decreases too. And we draw the experiment design by complete randomized design, with the population here is the water that contain cadmium and lead, and the water sample here is the 1 gallon of water taken from SIER Lake Surabaya, and the RA here stands for randomic allocation, which means the sample can be taken by any site. And X1 here is the sample control, and it is made by preparing one glass container and then mark 3 centimeters from the surface of the glass container, and then put some soil until the line, and then put the water from the gallon until it's full without spilling the water, and then wait for the soil to settle back down from scattering. And we don't close the container with any lid, knowing that the house garden is a healthy environment, so there's no special microbes or heavy metals that might affect the result in any way. And also to make the Marsilea crenata able to receive air and also to grow well without dying. And also the K2, you just need to repeat the steps in K1, and then at the end you need to plant 37 stalks of Marsilea crenata by plugging in its root. And also for K3, you just need to repeat the K1 steps, and also in the end you need to plant 74 stalks of Marsilea crenata by plugging in its root. And for the X1, X2, and X3 here means the same thing, which is by putting each container in a place full of sunlight and for 9 hours, and give a quiet distance in each container so that the shadow of each container don't block the sunlight for other containers. And at the end, we need to collect the data, the micro and the macro data, and especially for the micro data, we are using AAS as what I have explained before. However, I also explained in paper that the AAS have an error, and that's why, because it got some error, we need some time to search for other alternative that can help us in finding the cadmium and lead content in the water with the same result, which is by the milligrams per liter unit. And we find this inductively coupled plasma mass spectrometry. However, the time that we need for finding other alternative is quite long, and that's why we need have a delay in collecting the result and the data, and so that we ended up collecting the result in October 23rd, and we will share it to you guys right now. And the control variable in this experiment is the sample in K1. The independent variable here is the number of Marsilea crenata planted, and the dependent variable here is the cadmium and lead level and the turbidity. And the confounding variable here is the age of Marsilea crenata, bad condition of Marsilea crenata, and the lack exposure of sunlight. And also the mains used here is the 13 centimeter tall and with 9 centimeter diameter rounded glass containers as a container, and the AAS that have been changed into inductively coupled plasma mass spectrometry for collecting the microdata. And the time taken for this experiment is for 9 hours from 7 a.m. in October 22nd until 4 p.m. in that day. And it took place in a house garden, specifically in a place full of sunlight. And for the result and analysis, we have two types of analysis: descriptive analysis and analytic analysis. And for each analysis, we have two data that we collect. First is qualitative data, and second is quantitative data. Here's for the descriptive analysis. And then for the analytic analysis, this is for the qualitative data. And this is for the quantitative data. We have two data. First is about the cadmium content, and second is about the lead content. And there are some additional documentary. And in conclusion, the objective of knowing the effect of bioremediation in the turbidity of SIER lake water is done, with the result that with the more Marsilea crenata planted, the clearer the water, which means the more bioremediation occurred, the lower the turbidity is. And the objective of knowing the effect of bioremediation in the amount of heavy metals, cadmium and lead in the water cannot be done, knowing that the cadmium and lead content here is found that with the result not detected, which means it is below the reporting limit, and we cannot get an accurate amount. That's why we cannot see the specific change from the content in each of the sample, and that's why we cannot calculate it. And the objective of ensuring the amount of cadmium and lead on SIER Lake Surabaya is a factor of water pollution is done, with the result that the cadmium and lead content on the SIER Lake Surabaya is not a factor of water pollution, knowing that the cadmium and lead content in the water is less than the reporting limit, and knowing that the reporting limit is less than the threshold value. And the objective of proving Marsilea crenata bioremediation and knowing the effect of cadmium and lead on the turbidity of water cannot fully be done, knowing that for the turbidity it has been done. However, for the cadmium and lead, again, the result is not specific because it is written not detected, so we cannot find the answer. And we can also conclude 3 advantages of planting Marsilea crenata in a polluted area, which is economically friendly, not time consuming, and environmentally friendly. And suggestion for the researchers is that knowing that SIER Lake is not water polluted, if you want to research on especially about the Marsilea crenata bioremediation in reducing water pollution, do not do it with the SIER Lake water and just choose other water sources. And there are several of future works. One of them is like the effect of bioremediation of Marsilea crenata in reducing water pollution, because that's what we cannot do right now. And second is about the bioremediation of Marsilea crenata on other heavy metals, and so much more future works. Here are the reference. Well, that's all for today. Thank you for your time. Hopefully it is important for you, and God bless you.